Hello, everyone. Good morning, afternoon, good evening. I just wanted to thank you all again for joining us for this webinar. Your presenter today is Graeme Rocher, who's joining us live from Spain. I'm Jen Weesey. I work with the Grails and Micronaut team here at Object Computing, and we are so excited to have Graeme today, who is the co-founder of Grails and Micronaut and the technical lead here at Object Computing. And today we're really excited to have him to talk with us about Micronaut Data. With that, Graeme, I will turn it over to you.
Thanks, Jen. And thanks to everybody who is attending this talk. I look forward to giving you an introduction on Micronaut Data. For those of you who don't know me, as Jen said, I'm the creator of a couple of popular frameworks in the Java ecosystem, Grails and Micronaut. Technical lead Object Computing of those two, and have won a few awards along the way in my career for the open source work I've done. On the agenda today, we're going to look at an introduction of Micronaut Data. We're going to get a technical overview. We'll do a bunch of demos, and as Jen pointed out, we'll have plenty of time for Q&A and discussion at the end. First, a little bit of history of data access toolkits. I think it all began really with Rails, Ruby on Rails. That was, at least for me personally, the first time I was exposed to the typical pattern of the active record pattern in terms of generating dynamic finders and query methods that talk to a database. In the JVM space, I think GORM for Grails was the first to really bring that pattern to the JVM, using the dynamic nature of the Ruby language to really provide the same kind of capabilities that Ruby on Rails provided. And I think it was a pretty groundbreaking experience at the time in 2007 for folks on the JVM to experience active record-like behavior. Further along the line, along the history, Spring Data, other projects like Spring Data and Delta Spike, and a few others followed that eventually essentially copied the same approach. And it's become pretty common approach to, and a very popular one, to implement, automatically implement methods that kind of map your objects to and from the database. Majority of these tools, however, use runtime analysis, and I'm going to talk a little bit about that more. Essentially, if you look at existing data access solutions, including things like Spring Data and GORM, all of them rely heavily on the use of common patterns in Java, like reflection and runtime proxies. So what that effectively means is that most of your queries and the logic that implements those queries essentially get implemented at runtime. This has a cost in terms of computation, because you have to compute the queries at runtime, and normally that's done in a caching manner, so you can kind of compute it once and then cache it in memory and so forth. But there's definitely a cost of computation and memory consumption in terms of calculating those queries, computing them, and storing them. And as your application grows in size, you typically are going to have to pay a greater and greater cost as these computations need to happen. So with Micronaut Data, we wanted to revisit how these kinds of data access toolkits are implemented. And what we did was with Micronaut Data is that essentially it pre-computes your queries at compilation time. So instead of waiting to runtime to work out, how a particular method, such as find by name, maps to the equivalent SQL query, what we do is we statically analyze your source code and generate those queries inside of your compiler. And it uses Micronaut's reflection-free aspect-oriented programming mechanism, so that essentially there is pretty much zero overhead to using Micronaut Data as a database access solution compared to some of the other solutions out there. we also have support in Micronaut Data because we're doing things at compilation time for compilation time checking, so that we can assert that your queries that you're writing are actually correct at the compiler level, which is pretty important. And it's also the end result of all of this is because we're doing everything statically, everything's reflection free, everything's proxy free. We have much smaller stack traces, which helps debugging. It's important to point out number two, which I kind of passed over at the beginning, but essentially Micronaut Data is a solution for static queries. So be static analysis, where we can work out ahead of time what those queries are going to be. And we'll talk more about that as part of the presentation. So Micronaut Data currently comes in two flavors. We have Micronaut Data JPA, which has support for Hibernate and Hibernate/JPA. And what it does is it pre-computes JPA QL queries for your repositories. And this is really for users who prefer like the full ORM, object relational mapping experience that Hibernate provides. Hibernate is a very feature-rich object relational mapping tool with support for many different dialects and a lot of legacy schema support. So it's a lot, it's very rich, it's very mature, it's been around for a long time. Now the JPA implementation obviously doesn't use reflection and so forth at the repository layer, but Hibernate itself does still rely on reflection and runtime proxies. So it's not as optimal as the other variation of Micronaut Data, which is Micronaut Data JDBC. So Micronaut Data JDBC is where we've done a lot of really interesting work, which is essentially to support native JDBC. And it's not really an object relational mapping tool, it's more a pure data mapper. So it maps your SQL queries onto objects, and it's really focused on data transfer objects and immutable objects, and really discourages, unlike Hibernate, Hibernate and JPA are very much designed around mapping a single entity to a single database table, whilst Micronaut Data JDBC actually encourages the opposite, which is to create focused data transfer objects for each query that you may want to map onto. It's lighter weight and it's completely reflection and proxy free, which has numerous benefits, which we'll talk about soon. So in terms of a comparison of when you would choose one, JDBC versus JPA, there's very much pros and cons to each approach. Micronaut Data JDBC is much more efficient, requires less memory, is faster to start up, and doesn't use reflection, doesn't use runtime proxies. But on the other hand, it supports fewer dialects, mainly the modern SQL databases, with modern versions of the different SQL databases. It encourages the use of DTOs, data transfer objects. Not that those are impossible to use for Hibernate. They're also possible to use for Hibernate and JPA, but most people tend to use the single entity table mapping approach, which Hibernate really is optimized around. Another thing to point out is that Hibernate and JPA are highly optimized for writes. So if your application is write heavy, then you can certainly get a lot of benefit out of Hibernate and JPA, because the session concept and the concept of a Hibernate session or an entity manager essentially allows you to batch up a lot of updates and inserts until the session is flushed, which can produce much more optimized write operations. On the other hand, JDBC is much more optimized around reads, because reading the data is so much faster, and we have benchmarks showing that it's significantly faster to use Micronaut Data JDBC. I would argue as well that JDBC, if you're looking to go serverless, because of the low memory, the cold start performance, all of those things, it's far better. Whilst Hibernate does add its overhead in terms of runtime performance, both in terms of startup, memory consumption, and so forth. So they're two contrasting solutions, and it's really up to you which one you use. So let's have a look at Hibernate Data JPA first. So in the case of Hibernate Data JPA, you essentially define an interface, and we have some parent interfaces that you can extend from, like CRUD repository. And what you do is you annotate the interface with @repository. And what Micronaut Data does is during the compilation phase, it will look at all the methods, for example, find by name, and it will automatically work out the appropriate JPA QL query to execute. To perform CRUD operations, you can essentially call save to save an entity. On the repository, you can call read operations like find by name. You can do batch updates, so I can update a person by ID, and batch deletes are possible as well. So that's all via CRUD. So let's do some actual demos of Micronaut Data JPA initially. So I have an example project here, which actually I have, by the way, this example project, I went to micronaut.io/launch or launch.micronaut.io, and using Micronaut 2's new project generator, what I did was chose to use the data JPA feature and selected that. And then that will generate you a Micronaut Data JPA application. You can preview it if you want to see what it's going to generate. And more or less, this application that I generated is just purely based on a project generated from Micronaut launch. So with Micronaut Data JPA, again, you define your entities as you would normally do. In this case, I'll define a person one and have a generated ID, for example. And maybe we have a name, an age, and we generate some setters and getters for those. I'm going to create a couple of constructors as well, just to make it easier. So a default constructor, because Hibernate needs that. There we go. So there's my entity. And what you do is you define a repository, which, like I said, it can be an interface for an abstract class. And that repository essentially just has to be annotated with @repository. An empty repository is actually a valid thing, but in this case, what I'm going to do is extend CRUD repository, which defines some additional methods. And what you have to do is, with CRUD repository, you have two generic arguments. So folks who have experience with Spring Data as well will be familiar with this pattern as well. Essentially, the first argument is the type of the entity, and the second argument is the ID type, in this case, long. So that I have defined a person repository, and then we can define, dynamic finders, like, for example, find by name. And all of these get implemented for me at compilation time. So how would I go about testing this? We can use Micronaut test. So I can write Micronaut repository test. And this is going to be a JUnit 5 test, which I can annotate with Micronaut test. And what you can do is you can have a static void before all method that takes the person repository. And this can be executed before all my tests. And what we can do is save like an individual entity. So for example, I can say new person, Fred, 15 years old or something like that. And that will save an individual entity, but you can also call save all and pass in an array of objects. So in this case, maybe Fred, Bob, Joe, etc. Jeff, create a bunch of entities, entries, and James, etc. Okay, so there's some entities, so that will set up some test data. We can write an actual test that tests out my repository. For example, test count, and we can say set equals, place that with the stuff imports. So how many we got? 5. There we go. And now we actually want to be able to, invoke my repository. So what I can do is just inject it into my tests, like so. I could have injected it into the message signature as well, but I'm not going to do that. And there is a basic test for testing Micronaut data. So JP8 in this case. So if I run that, you'll see that hopefully the test passes. There we go. So that is, counting and this, you'll see that I got some SQL logs over here. And the reason those are appearing is because in logback.xml over here, I have specified to enable SQL logging for Hibernate. So we see the output of the different SQL statements that we are executing. So, we can also use the repository, like I said, to find a person by a particular name. So maybe we find Jeff in this case. And that's going to be Jeff. And then we say insert no Jeff. Set equals Jeff. And there we go. See how that works out. Hopefully it passes. And there we go. And it's working. So so that's essentially how you define and create repositories. And you can see it's very simple. Now that, like I said, there's some like type checking. So for example, if I were to rename this method to find by nom, which is clearly a mistake on my part, and I try to run that, you'll notice that I get a compilation error down at the bottom here, which states that person repository find by nom cannot be defined as a method because person does not define a property called nom. So let's undo that particular change. That's obviously undesirable. We can also do things like define JavaX validation constraints directly on the methods themselves, and I believe I have validation in here, which I do, and that will allow me to validate request parameters. So I believe if I did like repository find by name and passed in blank over here, I would anticipate that it's very likely that an exception will be thrown, which it is. And it says, find by name must not be blank. So we get built-in data validation using Micronaut validation rules, which are not specific to Micronaut data, but it's very nice that those are integrated nicely into Micronaut data. So what else does create a repository define? So if we navigate into the superclass, you can see that there's a save method, there's an update method, which we can pass in the entity to update. The save all method, which we used before, we can find an entity by ID. We can check if something exists by ID. We can count, delete by ID, and so forth. There's also another superclass which you can called pageable repository, which you can alter and subclass instead. And that one allows you to actually, page records. So you can say find all, and then pageable from page 1 to, and I only want 2, and that will return me a page records and so forth. And you can do pagination type tasks, which is clearly quite useful for paginating records. So that's a brief introduction to Hibernate JPA. Obviously you can see as well that the tests execute fast, and critically, one of the differences between this solution and others is that each method is actually computed into the bytecode at compilation time, and you can actually see that as well if I just test query. So if I write, say, a test query method here, and I do, and I get, if I inject the bean context, no, not that bean context, this bean context, and I say bean context dot get bean definition to get the bean definition for the person repository from Micronaut. There it is. And if I say bean repository dot get required method, and I say find by name string dot class, so that's the find by name method that we defined over here. And I say get method string value query or else no. That'll return me the pre-computed SQL. Or actually, this is not SQL, sorry, I'm using Hibernate. This is JPAQL. So up with that. And if we run this, you'll see that something went wrong. Find my method is not found. I think we have to actually, in order to retrieve the method, add executable onto it. Otherwise, we won't be able to retrieve it. And you can see that the JPAQL I've obtained from the annotation metadata. Yeah. So this is actually using the annotation metadata, which is encoded into the method and computed at compilation time. So the actual query is pre-computed. So in essence, all Micronaut has to do when executing your query is retrieve this query and delegate to Hibernate to execute and retrieve, which makes performance a lot better. So that's a little demo of Data JPA. So essentially, queries are formed by analyzing the method signature, and there's a method pattern, which is references part of the documentation. So you can say find, and find is not the only option. If you prefer to put search or get or query, you can replace find with one of those. And you can have an optional projection to get an individual value of a particular property, and then you say by. So in this case, find by and then name, and then you can optionally add order by to alter how the resulting query is ordered. So let's look now at Micronaut Data JDBC. So the difference with Micronaut Data JDBC is that, in the case of JPAQL and Hibernate, JPAQL is a abstraction over SQL that essentially gets translated into actual SQL at runtime. So with Data JDBC, we're generating SQL directly, and that means you have to involve a dialect. So with Micronaut Data JDBC, when you define a repository, essentially what you do is add JDBC repository and then specify a dialect. So in this case, MySQL is specified as the dialect. So folks often ask, why do you have to specify it on the interface? And the reason you have to specify it on the interface is because we actually, like I said, compute everything at compilation time. So the compiler has to know about the particular dialect that you're using. So, so as I said, the dialect is specified on the interface and then ensures that the compilation time computed queries use the correct dialect for the underlying database that you're targeting. And let's have a look at doing a demo of Micronaut Data JDBC. And I think when I do the demo, you will notice that a big difference in terms of speed in general of running tests and so forth. So what I'm going to do, the same kind of deal, is I'm going to create a person class, and we're going to, in this case, Micronaut Data JDBC does support JPA annotations if you prefer those, but I'm not, it just means you have to add another dependency, which so I'm not going to do that. Instead, I'm going to use the built-in annotations. So I've got a person, and similarly, we have an ID, which was a generated value, and this was the ID. And then we had some name property. And unlike Micronaut Data JPA, I'm going to make all of these final and immutable, apart from the ID, which needs to be assigned from the database. And then so I'm only going to have getters for name and age. So there's not going to be any setters for those. And I'll have a setter for the ID. You can also, if you use assigned IDs or IDs that are not generated from the result of an insert, you can also make that immutable as well. So this is my JDBC entity. Similarly, I'm going to have a person repository interface. And in this case, I'm going to use JDBC repository, and since I'm using H2 at the moment, I'm going to use the H2 dialect. And again, we're going to extend the repository interface and have find by name, etc. So, and then let's write the test. So person repository test. So to save a bit of time, so I'm actually just gonna skip over here and just copy and paste. I think I have a compilation error over here, but okay, remove that. So this is my the same test essentially as with Micronaut Data JPA. And I'm going to run it, and you'll see that when executing queries with, whoops, I think that one is, well, we can, the query one, which we can remove. I'm not interested in the query anymore. So let's run that again. Okay, there we go. So as you can see, this is more or less, let's get rid of that as well to avoid confusion. The same functionality, but instead, written with Micronaut Data JDBC. And you can see immediately just how, what a difference it makes in terms of my test execution. Whilst there was a little bit of a delay whilst the test was set up for Micronaut Data JPA and Hibernate, running tests with Micronaut Data JDBC is just lightning fast because there's nothing to set up. Everything is pre-computed. From the queries to the lack of reflection to everything, it's just much faster. The main difference being between JDBC repository here. And like I said, in general, Micronaut Data JDBC is very much focused around DTO objects. So although I have a mapped entity here, you could have multiple mapped entities, and you could have multiple DTOs, and it's really encouraged not to model a case where only a single entity maps to a single table. When you have a single entity mapping to a single table, what you end up having is suboptimal queries all over the place, because every single one of your queries ends up having to fetch all of the data from that exists in the table. Really, you only want to retrieve the data that's relevant to a particular query. So for example, if we elaborated a bit on this entity, and maybe we have add a hair color enum over here, blonde, red, brown, whatever, and we added another final attribute in here, hair color, and make the default being probably the most common hair color is brown. I don't know. And we add another secondary constructor to get all of that. So now we have a few different attributes. If I wanted to retrieve a subset of attributes and only get the attributes that I want from this entity, what I could do is create like an attribute. The attributes, the name of the DTO is irrelevant, but I'll just call it attributes DTO. DTOs need to be annotated with @retrospective. And what I can do is essentially only retrieve the attributes that I'm actually interested in. So maybe hair color, age. And again, we encourage with Micronaut Data JDBC the use of immutable objects. So those can be final, and we just have getters. I think probably I will need a getter for the hair color as well over here. And what that means is, I can write another query in here that just asks for the attributes of this of a person, and you can see that over here it's failing. So I'm asking for the attributes of Jeff, and we can see that hair color from Jeff or whatever. So what's going to happen here is, if I run that and it passes, you'll see that in the query that is generated, which you can see over here, Micronaut Data will automatically adapt and select only a subset of the data that is relevant for that data transfer object. So in this case, the data transfer object is only asking for hair color and age. So it only retrieves those two properties and doesn't retrieve the ID and the name and any other properties that are not requested as part of the query. And you can have, we absolutely encourage you to have multiple data transfer objects and really use the data transfer object to retrieve the data only the data you need for that particular query, which is important. Speaking of query logs, so you can see that all these are the queries that Micronaut Data generates, the compilation time being executed at runtime. For Micronaut Data JDBC to actually see the query logs, you have to enable query logging for the io.micronaut.data.query package and logger, and it'll essentially include queries and their values and everything in your log file. So that's how you enable query logging. Micronaut Data JDBC. So let's see, go back to my presentation. So with Micronaut Data, we absolutely encourage the use of like schema migration. So in the demos and for quick like demos, it's fine to use, you know, schema generation in Hibernate, and we've also got schema generation in Micronaut Data JDBC, but it's only really for experiments and quick demos. So you should absolutely pair Micronaut Data with a schema migration tool. Flyway is the simplest one and works nicely with Micronaut Data JDBC. Liquid-based is another option, which has, you know, a lot more features and abstractions and DSLs and all sorts of things, but is maybe more complex. But both great options. To definitely use schema migration. In particular, Micronaut Data JDBC, we encourage the use of data transfer objects, or DTOs, which are essentially just POJA objects like I demonstrated that are annotated with @introspective. They absolutely can and should be immutable when possible, so that you're just retrieving the data and that you need. In terms of transaction management with Micronaut Data, you can use either Micronaut or Spring transaction management. Both are supported. In all of the examples that I've shown so far, it's using Micronaut's transaction management, which also allows you to use programmatic transactions. So this example here is using JPA, but you know, you can equally use Micronaut Data JDBC transactions and so forth. And it's essentially a matter of injecting the transaction manager and calling execute write for a write transaction or execute read for a read transaction. And within that context, it will perform a programmatic transaction. We also have support for @transactional in Micronaut's transaction manager. And for that, you can use javax.transaction annotation, and that works fine for declarative transaction management. So the other important thing to point out, which I pointed out at the beginning of my talk, is that Micronaut Data is very much a solution for static queries, not dynamic queries. So queries that you know ahead of time what they're going to be, and that's where its real strength is. If you're looking for a solution for dynamic queries, then you know there's many of those out there, and that you can pair with Micronaut Data, combine with it, and we absolutely recommend that. So, for example, in JPA, obviously you have JPA criteria, which is for designed around dynamic queries. You also have in the more JDBC world, you have tools like Juke and JDBI for dynamic queries. So a nice pair, if you're going with Micronaut Data JDBC, is Micronaut Data JDBC plus Juke, or Micronaut Data JDBC plus JDBI, which are both nice solutions where you use Micronaut Data JDBC for the static queries, and anything complex or dynamic, delegating to one of those tools. So do have a look at those, and Micronaut has great support for all of these solutions. In terms of native image, both JPA and JDBC implementations support GraalVM native image, so you can build native images. The currently released version of Micronaut Data supports, does require a few tweaks when you switch to a different driver, and those are documented at this URL. So you basically have to add a bit of configuration. But we are happy to say that massive improvements are coming in Micronaut 2 and Micronaut Data 1.1, where those requirements will essentially go away. So you won't have to even configure your driver or your dialects or anything like that. It'll just happen automatically, which is going to be a nice improvement to Micronaut 2. So I can recommend you check that out. But you know, either way, whether you choose JPA or JDBC, we support native image. Now, Micronaut Data JDBC, because it's smaller and doesn't have reflection and requires a lot fewer dependencies, produces much shorter build times and much smaller native images. So again, another reason to consider Micronaut Data JDBC if you're looking at native image over JPA, because you will essentially have smaller images, more efficient images with Micronaut Data JDBC. So in terms of the Micronaut Data roadmap, 1.1 is coming out soon, and we've got a few little improvements in there. Like I said, we have better support for UUID at the schema level. We have support for identity columns in Oracle. We have improvements to GraalVM. And then our next focus on Micronaut Data towards the latter part of the year is to introduce support for more reactive support through RTDBC and support for MongoDB and Neo4j. Now, MongoDB and Neo4j support, I don't imagine will take too much time because, or even RTDBC, because the queries we generate is going to be the same. It's just a different runtime. So I don't imagine these things will take too long, in particular MongoDB and Neo4j, because an interesting fact for some of users of Grails or Gorm is that Micronaut Data code base is actually largely based on a fork of the query generation, at least, is based on a fork of Gorm. So Gorm for Neo4j and Gorm for MongoDB already exist, and we will likely again migrate some of that code to Micronaut Data to support those two databases. So it won't be like we're starting from scratch. So in summary then, Micronaut Data fits naturally into Micronaut applications. It's basically a zero overhead database access solution, especially if you go with JDBC, which provides significant benefits in terms of runtime performance, memory consumption. And if you pair it again with GraalVM native image, you are going to have a phenomenal experience in terms of memory consumption and startup time, which is becoming increasingly important for serverless cases, such as running Micronaut on Lambda. Micronaut 2 has a big push towards serverless with support for even massively improved support for AWS Lambda, support for Microsoft Azure functions, support for Google Cloud functions, and a whole bunch of improvements to GraalVM native image support. And with that is my presentation. So I will now switch over and we can start taking questions.
All right, thanks, Graeme, so much. And thanks all of you for tuning in today and all of your questions. We've had a lot of them come through. I know Jeff's been answering some of those live in the Q&A and in the chat while Graeme was talking. And we've got some queued up here, so we'll go ahead and I can read those off, Graeme, for you, and you can go ahead and take those. I'll just start here from the top, and some of them you may have already answered in your conversation, but and then just let me know, and I'll just keep going down the list. So does the JPA mode of Micronaut Data also support extensions? And there's a link here from Vlad at, he put it like a GitHub link here for Hibernate type.
Yes, absolutely. Micronaut's JPA support is very flexible so that you can plug in whatever extensions that you want. Essentially what you would do is with Micronaut, you will be, you can essentially register what's called a bean created event listener. So I can say I'm going to create a bean created event listener for the session factory settings, and you can wire in whatever extensions that you want into it as part of your application code. Probably we need some more documentation on that subject for the Hibernate JPA module. But essentially, you can see in Entity Manager. Now this is so this is the factory class that creates all of the different beans for JPA and allows you to wire in, for example, an interceptor, which is a common extension point for, so you just declare your own interceptor bean for Hibernate. It allows you to create the standard service registry. So what you can do is essentially define a being created event listener for the standard service registry, and then customize that as where you see fit. And that's again another extension point that you may want to integrate with Micronaut. Again, metadata sources is another typical extension point. So you can maybe create event listener for metadata sources and wire them in there. So there's various options to make it, to extend and replace how JPA is configured. Again, the session factory builder, you may want to customize that and apply different validators, all sorts of things. So those are all easily plugged into with Micronaut.
All right. We got another one here. Does Micronaut support stored procedures?
Yes, so I probably should have demoed that. Actually, is that you essentially can declare a at query, and this can just be a native query. So you can, whatever SQL or stored procedure logic that you want can go in there, and you can essentially execute it. Gets executed, and it's just a matter of whether the result maps to what you want. We also have obviously write queries. So, for example, for batch updates, you can do update whatever or delete and write whatever manual queries that you prefer with that query.
So here's another one. Can you change the JDBC dialect in config level?
So not currently. That was because we essentially compute the queries at compilation time. So the dialect has to be set at compilation time. So we may consider adding that in the future, but it would require recomputing the queries at runtime, which is obviously undesirable. So like I said, it's for JDBC, it's definitely the case that it's a trade-off that we've dealt with in terms of, we want to compute as much as possible ahead of time so that we can achieve this phenomenal cold start performance and memory consumption that we have. And if we allow that tweaking and customizing at runtime, then it would essentially degrade the runtime and memory consumption performance, which we want to avoid. So no, the dialect has to be currently specified at this level. If you do want to support multiple dialects, you can have different repositories. So you can have a parent interface, for example, person repository, and then subclass this interface and have like a MySQL person repository and a Postgres person repository, and inject different ones by name depending on what you want. And that's the approach that you can take. It just requires structuring your application just a little bit differently.
Okay. Oh, and I see a comment here from Ryan. It says, great presentation. I already made 3 improvements on my new internal project around Micronaut Data from this. So thanks for sharing, Ryan. That's super cool. And then is there a simple way to generate the JDBC or JPA definitions from the DB metadata as we did in Grails and Gorm?
You mean the SQL? I assume you mean the SQL. Yes. So in this case, I'm actually using that schema generate option to generate the schema. But like I said, it's not a replacement for a database migration tool. It's really just for quick demos and so forth. So the schema is being generated automatically, and you can use that class. The class itself is called schema generate or something. Schema generator. And you can use it to create the schema if you want, and output it and so forth. But like I said, it's far better to choose something like Flyway or Liquibase to handle that task.
All right. It says if you have mapped multiple entities, then in that case, should we need to have multiple repository classes?
No. So, you know, as demonstrated in this example, you can, this is like the default repository, the default class that gets used. But you know, I could specify any other entity in the return type here. And as demonstrated in this example, I'm using a data transfer object as the return type. So you can have multiple methods and they don't all have to do return person. They can return different DTOs, they can return whatever you want. And that allows you to, you know, return just the data that you need to query. And of course, if you need like pagination as well, you know, you can easily add a pageable argument on here to allow pagination of this query and so forth. So it's very, very customizable. And no, you don't need to have different, you know, just one multiple repositories for each entity definition. In fact, we discourage that. You
know. Okay. One here from Brian. In JDBC, are batch inserts and updates run as one query or multiple queries?
So when you do like here, where I'm doing save all, this is done as a single query, single insert. But there's no session concept, so you know you have to make sure that you essentially call save all with all the data that you need. So if I was to write something like this, people, and I was to do something like this, that would produce five inserts, right? So, and we have some optimized smarts around like cascading updates and inserts and so forth for inserting associations. But like I said in the presentation, if you really have a write-heavy application, then oftentimes Hibernate and JPA can be better for those use cases, because the notion of having a session and being able to batch up with a kind of stateful model that JPA promotes is sometimes very good for write-heavy applications. But you know, there are ways to essentially implement patch operations with Micronaut JDBC that don't execute multiple queries, like for example using save all instead of this pattern, or as well, you know, defining your own save operation that uses a custom query, you know, insert or whatever, and then, you know, run the query with the data that you want. So there's multiple ways to do batching. It's just how you want to handle that.
All right. Does Micronaut Data versioning align with Micronaut Core versioning? So for example, when they need to be on 1.x or 2.x to work with each other?
No, they all, in general, all Micronaut modules are decoupled from Micronaut Core's version model, and there's no correlation necessarily between what version of Micronaut Core and what version of Micronaut Data. Now, in general, we document the minimum version of Micronaut required to use a particular module as part of the documentation. So you'll note that in the recently released Micronaut Data 1.1 documentation, which is somewhere over here. Let's have a look. We specify in the release history when a minimum version requirement changes. So in this case, Micronaut 1.1, which will be the next version, which will ship as part of Micronaut 2, will require Micronaut 1.3 as a minimum version. But no, there's no correlation between the Micronaut version and the Micronaut Data version.
All right. And are major versions of Data and core Micronaut linked? Where do they check that compatibility?
So generally, like I said, in the documentation for each module, we always, whenever we change a minimum version requirement, we put it in the release history. You know, but with Micronaut, in general, the binary format that we produce at compilation time, bytecode format that we produce at compilation time is the same between Micronaut 1.x and Micronaut 2, so that there shouldn't be any real breaking changes in that respect.
Okay. Is multi-tenancy supported?
Not yet, but it's one of the things actually I should have mentioned in the roadmap for Micronaut Data 2. So we want to add an eventing model and make it easier to plug in your own interceptors and so forth, and that will be multi-tenancy will form part of that, which will be in Micronaut 2, Micronaut Data 2.
I'm sorry, if you don't mind if I jump in. There's a couple I'd like to flag in particular for discussion.
Sure.
If you don't mind,
yes, please go ahead.
So Graeme, one question is, will you support standard JSON databases, Couch, etc.? And then he follows that up with a claim that Mongo is not simple JSON. But can you maybe just speak briefly to kind of the future of different types of databases, in particular standard JSON databases?
Yeah, sure. So like I mentioned in the presentation, MongoDB support is on our roadmap for Micronaut Data 2. And you know, a number of users have requested that already. And couch-based support is not for Micronaut 2, but that doesn't mean there may not be a community contribution in that respect. We have lots of recent community contributions where folks have implemented support for things that haven't come directly for us, like support for NATS.io, for example, which is a recent one. So that may materialize. In terms of supporting MongoDB and document databases in general, it's actually generally a lot easier than relational databases. Relational databases are way harder to model and map queries, at least in my experience building Gorm for MongoDB, where it was much simpler to implement than say Gorm for Hibernate or anything else, or Micronaut Data JDBC. There's generally only one dialect to deal with. The JSON object model maps much easier to the Java POJOs, so it's definitely less challenging to do so. And we already have an implementation out there with Gorm for MongoDB that we built that we know works and people like. And I don't think it will take too long to port it over to Micronaut Data.
Yep, good info. And those are, for folks who have been involved with Gorm over the last decade or so, know that so with Gorm we started with just Hibernate support, and then we had JPA support, and then started adding support for fundamentally different databases. And today we've got support for Neo4j and MongoDB and a bunch of other data stores. And I don't think it's the case that Micronaut Data will necessarily take the exact same path, but we've got experience evolving persistence technologies across these fundamentally different kinds of databases. And I think we'll see more of that moving forward. Maybe one last question. John asks about, are there any issues with using Groovy? And part B to that is especially with GraalVM. You want to speak to that briefly, Graeme?
Yeah, so there's no issues using Groovy with Micronaut Data. We have built Micronaut from the very beginning to support a variety of different languages. So at the moment we support Java, Groovy, and Kotlin, and we've done that in a manner where we've written specific compiler plugins for Groovy and Java and Kotlin that integrate with those languages. And I believe our most voted for issue right now is on our Micronaut cores issue tracker support for Scala. So I think a lot of Scala users are out there are interested in Micronaut support, and we have to look at that at some point. So we absolutely support Groovy and Micronaut Data. Now, in terms of GraalVM, that's obviously a different story. GraalVM in general works a lot better with statically compiled closed world scenarios, which is a little bit harder to achieve with Groovy. It's not impossible, but it's definitely easier to get applications running with Kotlin or Java on GraalVM native image. So that's something you should consider if you're looking at going in the native image route or route for our American friends. And yes, absolutely consider that if you're looking at adopting native image.
Thank you again, Graeme, for your time, and thank you everyone for joining us. Sorry we didn't get to everyone's questions, but we will we'll try to follow up with you, and if you don't get your question answered by Graeme in the Getter channel. So thanks again, everyone, and we look forward to seeing you at our next webinar.
Thank you.